Welcome to Rubixx Structures, where we teach how to design structural elements, both in reinforced concrete and steel structures. On today's tutorial, I'll be teaching you how to design a raft foundation using Orion. Raft foundation using Orion. Okay, if you're new to this channel, please do well to subscribe to the YouTube channel, like this video, and also drop comments. Right, so let's get right into it. Okay, welcome back to Rubixx Structures. On today's tutorial, I'll be teaching how you're going to design raft footing, raft or mat footing using Orion. Alright, so let's get right into it. Alright, so the first thing you're going to do is you're going to come to your story 0. You're going to be at your story 0. Okay, we can check our 3D view so you can see our building, what it looks like. So this is our building. This is what our building looks like. We want to have a raft footing for this. These are buildings, so we want to have a raft footing for this. Right, so you come back to your plan view, story 0. Okay, so the first thing you're going to do is that we need our raft beams. Alright, so we click on beams. Alright, we're going to be having a 225 by 750 deep beams. Okay, so this is where directional beams should go. Okay, here, all right, here. Okay, so we're going to even have it horizontally on ground beams. Okay, so this would be here, this would join here. Okay, so this one will join from here to here. Okay, so this is how our ground beams would look like. Okay, you can escape that. So this is what our ground beams look like. So the next thing we're going to be adding, aside from the ground beams, is going to be a slab. Right, so we come to slab. Okay, we're going to be using a 200 mm thick raft slab. Our concrete cover is going to be 50. Okay, remember I told you that for foundation, especially the ones that have come in contact with the soil, you need a very large amount of concrete cover to avoid soil action. With a lot of concrete cover, it increases the lifespan of such foundation because you can't have some chemical reactions on the concrete. With the 50 mm thick cover, it's going to be difficult for it to have come in contact with your reinforcement, thereby destroying your foundation. So it's good you put a cover of 50. Come to load. Dead load is going to be 3. We're going to be using dead load of 3, and it's a residential building, so we're going to be using an imposed load of 1.5. Alright, so this dead load incorporates wall loads. We are loading all our wall loads and floor finishing, and this is sums up to 3. Okay, so we're just going to click and insert our slabs. Alright, so to click that, and we're going to insert our slabs. Can escape and come to 3D view. Come to 3D view so you can see what you've done. Okay, this is what you've done. Have a raft, and you have your raft slab. Okay, so in practice, usually this is not how it looks like. In practice, what it looks like is that our slabs are always on top, so we need to change that. Okay, I just wanted to include that so you could learn from the process. This slab has to be on top, right? It's not down here. The slab is usually on top. You have your ground below, you have your slab on top of it in practice. So what you do, you have to come back to our plan view. Okay, so you click on the slab, right click on its properties. So you're going to come to load, and you're going to come to the level. Okay, so 750 is depth of our beam 750, and thickness of our slab is 200. So 750 minus 200, we have 550. So we're going to put level of 550 here. We're going to update that, and we're going to close it. So we're going to just do one so we can replicate it for the rest, so we can come 3D view. If you zoom into it, you're going to see this is the perfect location where it's meant to be. Understand? Because in practice, you have your ground beams, then your slabs are on top of your ground beams, your mats. Your raft is usually on top of it, not below it. Alright, so we need to correct that. Click on plan view. Same thing, you click. You're going to select. So you click on one, hold your control key. Hold your control key. Click on one, hold your control key. We can right click, come to properties, and okay, so we have desired here. This is it. You can click on this, you come here. I'm going to change that to 550. Click OK. I'm going to close it. Once you close that, you can come back to your 3D view just to confirm. Okay, so that is where your raft is meant to be. Okay, that's where your raft is meant to be. Next, we can come back to our plan view. After that, come back to our plan view. Next, we are going to be inserting. We are going to be inserting our strips. Okay, so you click here, strip. We are going to be using finite element strips, since we are going to be doing the finite element floor mesh analysis for this, for rafts. Okay, so we are going to be using this. You come back to this, and it's going to be X. You're going to X direction horizontally. Okay. You're going to have first hold your control key to make it straight. Okay. And also here for this. X is going to be in the right direction. So you just hold it, make it straight. Hold it, make it straight. Alright. So that is it. After your strips, come to run, you're going to see finite element raft foundation analysis, FE raft foundation analysis. So you click on that, give it time. So before you run your mesh, you have to come to your post analysis and make sure you change the allowable stress of soil to whatever your soil report gives you. In my case, my soil report gives me 75 kilonewtons per meter square for my soil allowable stress of soil. That's my bearing capacity. Okay, you can change that to whatever it is on yours, but for mine is 75. Come back to floor mesh and analysis. I'll keep this ticked on. Consider beam torsional stiffness. Okay, subsequent videos I'm going to explain why when you need to click each of these, but for now just keep it at consider beam torsional stiffness alone. Alright, and once you're done with that, you just do wrapped foundation mesh. Alright, so I just click yes. Okay, so this is what we have. I'm going to generate model. Okay, so if you want to generate model, it has broken the slabs into smaller bits. Okay, into smaller mesh. Alright, so when you're done that, you close. Once you close, you give it time for it to do the finite element rafts foundation analysis for you. Okay, this takes a very short while. It won't take way too long. It will take a very short while before it comes up. Once that is done, it takes you right next to the post analysis processes and reports. Alright, so that is it. So next you're going to do is you come to analysis post processing. You click on it, analysis post processing, right, and you would have this. So if you zoom into it, you're going to see your strips. Really, this is your strip in the right direction, this is your strip in the X direction. So if you zoom into it, on the nodes at the column positions, you notice that you see the axial load. At this column position, the axial load on this particular node here is about 252.9 kilonewtons. and the moments in the x and y direction are 0.1 and minus 2.4 respectively. Same with other column positions. We have here, we have 36 and thereabouts and every. Okay, so what you can do now, you come to general. Once you're in this page, come to general, you can maximize this. Come to general, you have to change to plan view. Okay, in the plan view, then come to results. So we're going to be using threshold contours. Click on threshold contours because we want to insert reinforcement ourselves. So you come to threshold contours. So once you come to threshold contours, you come to the right side of your screen. You have the design moment. Once you click on it, you realize from the contours you can know where the moment is using the legend here. Okay, so you have, if you have it, if it's this, can zoom in to see that perfectly, but you want to insert reinforcement for this. What you next thing you need to do is for you to come to your area of steel. Click here. Okay, this for the bottom, along the bottom steel, so you can click there. Then once you click on that, you can come to edit contours. Okay, so it's telling you that the red here tells you the reinforcement it needs. So it tells you the reinforcement you need, so you can just click it, tell it to set nominal reinforcement using Y12. If you're using Y12 and you're using a spacing of 100, for example. Okay, once you put here, you realize that Y12 a spacing of 100 will give you an area of steel of 1130.97. Okay, so you click OK, and you must make sure that what you're providing here, what is here, you must make sure that what is here is more than what is outside here. Okay, that's when you're provided adequate reinforcement. Okay, so it's telling you for the bottom reinforcement it needs this, so we have provided Y12 at 100. Okay, which is adequate, so you can click OK for that one. All right, so you click on the next one, same thing, edit contours. It requires 1092.50, so it's set nominal, same thing, Y12, and we're going to be providing Y12 at 100. Okay, Y12 at 100. Let's try 125 to see. It's not up to Y12 at spacing of 125 is about 904, and we're looking for 1000 plus, so we're going to space that at 100. Okay, so now the area is 1030.9. Okay, so you click OK. Make sure you confirm, like I said earlier, make sure you confirm. Okay, click OK. For top, same thing. For top, we need to edit contours, so it requires 573.59 to set nominal steel. Need Y12, so Y12 at 250 doesn't work. Y12 at 200. Let's see, click OK. It doesn't work. See, here is 565.49. Meanwhile, we are requiring 573.59. That's not okay, so you have to set that and make sure it works. Y12 at 175. Okay, so now you realize that Y12 at 175 gives you 646.24, which is more than enough for this, so you can click OK. Come back here to same thing, edit contours. It requires 712, so you set on a reinforcement Y12, say at 150 for example. So click OK. That's okay, so you can click OK. You can still come back here and edit contours, and let's provide at 150 here also. All right, so click OK. So you have successfully provided reinforcements based on the mesh analysis. So you can click on your saw pressure. Okay, all right, so that is that. Once you're done with that, once you provided adequate reinforcement, you can just end that. Okay, so it's now telling you, do you want to transfer slab strips? Okay, so you just click OK and give it time So now it's, you see, it's transferring slab strip results. It has transferred to the first strip, that was x20, now it's x21. So it's going to transfer it to all the strips you provided earlier. So now the next one is x22, to provide for the next one, which is x23, x24, and so forth, and so on and so forth. Alright, so I think that's done. Once that is done, the next thing you're meant to do now is for you to, you can transfer this. You click transfer and you click OK. Okay, so that is that. So once you transfer it, you can close that. And even when you've closed that, you realize that it still hasn't provided reinforcement on your strip. So the next thing you're going to do, so it provides reinforcement, is for you to right click on it here, and you click on arrange steel bars, click on update steel bars, and once you do that, it now provides those reinforcements. So if you zoom in, you check and see those areas where it provided and how it provided the reinforcements. Okay, so to 150, and that's, so this is how it provides the reinforcement. So that's how you design raft footing on Orion. Hope you learned something. Please do not forget to subscribe to my YouTube channel, like this video, please drop comments where we can help you. Thank you.